Question 4, part A, we need to find the values of x for which 2x plus 1 all squared is less than or equal to 3x plus 4. So we'll start by expanding the left-hand side of the inequality. So we're going to get 4x squared plus 4x plus 1 is less than or equal to 3x plus 4. Just move that 3x plus 4 to the left-hand side. So we get 4x squared plus x minus 3 is less than or equal to 0. Now this one's not too bad just to factorize by inspection, but I'll just go through a more systematic approach. So we're looking for two numbers that multiply together to give negative 12, because there's 4 times negative 3 is negative 12, and add together to give x. So that's going to be positive 4 and negative 3. So we can write that left hand side then as 4x squared plus 4x minus 3x minus 3 is less than or equal to 0. So then we get 4x x plus 1 minus 3 x plus 1 is less than or equal to 0. And then factorizing fully, we're going to get 4x minus 3 times x plus 1 is less than or equal to 0. So now we want to find the critical values. So that's when that left hand side of the inequality equals 0. So we'll note that down. So the critical values, well, the left hand side equals 0 when 4x minus 3 equals 0 or x plus 1 is equal to 0. So if 4x minus 3 is equal to 0, that means x is equal to 3 over 4. And if x plus 1 is equal to 0, then x is equal to negative 1. So we know then when that left-hand side of the inequality is equal to 0, and we also need to find, well, when is it less than 0 as well. So to do that, we're going to make a sketch of the graph. So we're going to sketch that graph 4x squared plus x minus 3. And to do that, well, I'll just bring up a set of axes. Now we know we've got a positive shaped parabola because our coefficient of x squared is positive. And we know our x-intercepts, so they're negative 1 and 3 over 4. So we'll mark them in. So if this is our x-axis, this is our y-axis. So I'll mark in negative 1 and 3 over 4, so about there. Now it doesn't have to be a super accurate sketch or anything. It's just to give us an idea of when the graph is going to be less than or equal to 0. So it's a positive shaped parabola. It's going to come down and then it's going to come back up and cut our x-axis again at 3 over 4. So it's less than 0 or less than or equal to 0 in this region here. So that means x has to be well, greater than or equal to negative 1, but less than or equal to 3 over 4. So our answer then is going to be x is less than or equal to 3 over 4, but greater than or equal to negative 1. Okay, so that is part A. For part B, we need to show that for whatever value of k, this equation here has no real roots. So that means its discriminant must be less than 0. So the discriminant is b squared minus 4ac, and we must have that less than 0. So for our equation in this question, our a is going to be equal to 1 over 4, b is equal to k, the coefficient of x, and then the constant term, which is independent of x in that equation, is going to be our c, which is k squared plus 1. So working this out then, our b squared, well, that's just going to be k squared, and then minus 4 times a times c. So it's going to be 4 times a quarter times c, which is k squared plus 1. And we need that less than 0. So just simplifying that left-hand side, so we're going to get k squared minus, well, 4 times 1 over 4 is just 1. So we're going to have k squared minus k squared plus 1, and don't forget the brackets there, and that has to be less than 0. Well, k squared minus k squared, that is just 0, and then we're going to be left with negative 1 on the left hand side. So we get negative 1 is less than 0. So what we can say then is we can say that the discriminant is independent of k and it is less than 0. So we'll just write that down. Okay, and that will give you 4 marks for part B there. Okay, so that finishes question 4.